everyone! Welcome back again to my YouTube channel. It's always been your host, Sherlina Agcopra, to talk on laws to follow. Just like in our real life situation wherein we are guided with some rules to abide to make our lives not miserable but meaningful. So with math, we also have laws of exponents to follow and be guided to a correct and easy solutions to our problems. Because math matters too. So let's get started with laws of exponents. Relax and enjoy our math.
Yes! Hello everyone! Welcome back again to my YouTube channel. It's always been your host, Sherlina Agcopra. But before we proceed to our main topic, don't forget to like, share, and subscribe my YouTube channel. Okay? So sit back, relax, and enjoy our math since math matters. Okay? Enjoy the music first. Don't forget again to subscribe my YouTube channel. So let's get started with the laws of exponent. If a is a real number and n is a positive integer, then we have this symbol, a to the power of n is equal to a times a times a, and so on and so forth up to a, where our n here, which is the exponent, are factors of a. Okay? Next, as you can see, the symbol a to the power of n, where our a is called the base and n is the exponent. So here, where n is called the exponent and a called the base, and a to the n power is called the n power of a. Next is the product rule. If n and m are positive integers and a is a real number, then a to the power of n times a to the power of m is equal to a to the power of n plus m. Example, x squared times x to the fourth power is equal to x to the power of 2 plus 4, so we have x to the power of 6. All you need to do is to add the exponent if the base are the same or the bases are the same. Example, we have x squared and x to the fourth. Notice that the base x are the same. So all you need to do is to copy and add the exponent. So we got x to the power of 6. Okay? Example A. How do you read this one? To read is the quantity 3x squared y squared cubed times the quantity of negative 5xy. Ulitin natin. The quantity 3x squared y cubed times negative 5xy. Or you can also say that the product of the quantity 3x squared y cubed and negative 5xy, or the quantity negative 5xy. Okay? So you should know how to read. So the first method or procedure to do is to multiply first the numerical coefficient of these two quantities, 3 and negative 5. So you have here 3 times negative 5. And then the base x squared, and x, we have here power of 1. So we got x to the power of 2 plus 1. And for the y, you have 3 and 1. So y to the power of 3 plus 1. Okay? Then, simplifying, you got 3 times negative 5 is negative 15. And then for the x, you have 2 plus 1, you got 3. And for the y, you have 3 plus 1, you got 4. So the product of these two quantities is negative 15x cubed y to the 4th power. Okay? Okay, next example. How do you read this one? Okay, the quantity a cubed b to the 4th times the quantity a squared b squared c. Okay, applying the product rule, you got a cubed and a squared here, one quantity. And then for the b to the 4th, b squared here. And for the c, and then applying the product rule, you have the same base a, copy, and then add the exponent 3 plus 2. Okay, for the b, notice that they have the same base b here, and then add the exponent 4 plus 2, and then c. And then simplify further, you got a to the power of 5 taken from here, b to the power of 6 taken from here, and then c. Okay, very easy if you just listen and analyze the problem so you can solve correctly. Okay, next is power rule. If n and m are positive integers and a is a real number, then a to the power of n raised again to the power of m is equal to a to the power of n times m, or the product of the exponent. Okay, example. X squared raised again to 4 is equal to x to the power of 2 times 4. And then simplify further, you got x to the power of 8. Okay, that is under power rule. Okay. Okay, we have again another example. Quantity negative c to the 5th power raised again to another power of 2. Here, you have the expanded form, negative c to the power of 5 times c to the times negative c to the power of 5. Since here we have in second power, that's why we have this part here. Or you multiply 5 times 2, applying the power rule. So you got 5 times 2, you have 10. Or apply the product rule, you have 5 plus 5, since they have negative, the same base, negative c here. So you got c to the power of 10. Why it's positive, ma'am? It's because the exponent is even number. When you multiply negative c 10 times, so the product is positive. Okay, that's why you have c to the power of positive. Next example is quantity negative x cubed raised again to another power 3. You can directly solve by copy the base, negative x, and then multiply the exponent 3 times 3. Or the expanded form, applying the product rule. You have negative x cubed times negative x cubed times negative x cubed 3 times, no? Because of this power here. And then add the exponent 3 plus 3 plus 3, you got negative x to the power of 9. Negative x, since our 9 exponent here is 9, it's an odd number. That's why you got negative x to the power of 9. Okay? Don't be confused. Analyze first and so you can solve it correctly. Okay? Okay, next rule is power of a product rule. If n is a positive integer and a and b are real numbers, then the quantity a times b to the power of n is equal to a to the power of n times b to the power of n. Example, you have here x, y, or the quantity x times y squared is equal to x squared taken from here and then y squared, or x squared y squared. Okay? So let's have an example of a power of a product rule. We have here quantity of 2x squared y squared raised to a power of 4. All we need to do is to apply the power of a product rule. 2 to the power of 4 and then x squared taken from here to the power of 4 here. And then y squared here to the power of 4. And then simplify further, you got what is 2 to the power of 4 is 16. And then x, 2 times 4, you have 8. And then for the y, 2 times 4, you have 8. Or 16x to the power of 8, y to the power of 8. Okay? Next example. You got the quantity of negative 2p times 2 cube raised to the power of 3. Okay? So you got negative 2 from here and then raised to 3 from here. And then p from here and then raised to 3. That's why you have here. And then 2 to the power of 3 here. And then cube from here raised to 3 here. And then simplify further. What is negative 2 to the power of 3 is negative 8. Since our power here is even, rather odd, we got negative 8. P cubed. And then for the 2 raised to 3, you have positive 8. Since this is positive, the base is positive. And then q cube raised to 3, or 3 times 3, you got 9. So multiplying the numerical coefficient of these two, negative 8 times 8, and then for p, and then for q, you got 64, or negative 64 p cube q to the power of 9. Applying the power of a product. Okay? Very easy. Next is, yes, in our quotient rule, we have this statement: if n and m are positive integers and a is a real number where a is not equal to 0, then our formula is a to the power of n over a to the power of m is equal to a to the power of n minus m if n is greater than m. Next, what if n is less than m? You use this formula, 1 over a to the power of m minus n. And the last condition is, if n is equal to m, then this statement here, where our a to the power of n over a to the power of m is equal to 1 if our n is equal to n. Okay? So let's have an example. A to the power of 6 over a to the power of 4 is equal to x to the power of 6 minus 4, applying the first condition if n is greater than n. So simplifying, you get x to the power of 6, or rather 2, or x squared. Next is c to the power of 4 d to the power of 6 over c to the power of 2 times d is equal to c, since they have the same base, c, you apply the first condition where m is equal to, or rather our n is greater than m, 4 minus 2. And for the d, 6 minus 1, because we have here 1. Then simplify further, you got c squared d to the 5th power. Okay? Next is power of a fraction rule. If n and m are positive integers and a is a real number where b is not equal to 0, then a over b raised to n is equal to a to the power of n over b to the power of n. Example, quantity x over y raised to 3 is equal to x cubed over y. Okay? So, here's another example of a power of a fraction rule. So you have m squared over n raised to 5. Then you have m squared taken from here times 5 taken from here over n to the power of 5. So you got m to the power of 10 over n to the power of 5. Okay? Next is the quantity 7x cubed over 9y squared raised to 3. Then you have here a 7 cubed here, and then x cubed times 3 taken from exponent here. So then 9 cubed, then y squared times 3. And then simplify further, you got 9, or rather 7 cubed, x, 3 times 3, you got 9. And then for the y, over y, 2 times 3, you got 6. And then simplify further, 7 cubed is 7 times 7 times 7. And what about 9 cubed? It's 9 times 9 times 9. And then you got 343x to the power of 9 over 729 y to the power of 6. Okay? Next rule is zero exponent rule. If n is a positive integer and a is a real number where a is not equal to 0, then a to the power of 0 is equal to 1. Example, x to the power of 0 is equal to 1. Okay, let's apply to another example. Okay, we have more examples. Applying the 0 power, you have 7 to the power of 5 over 7 to the power of 5. Notice that our n and m here are equal. So you can apply the third condition for this one. So you got 7 to the power of 7 minus, rather 5 minus 5. That is 7 to the power of 0. And that will be equal to 1. Okay? So next is 8x squared y to the power of 0. This part here, y to the power of 0 is equal to 1. All you need to do is to simplify 8 times x squared times 1. And then you got 8x squared. Another example for letter C, the most easiest part. The quantity for x squared y cubed raised to 0. Here, 0. So anything that is any base raised to 0 is equal to 1. Okay? Very easy. Next is negative exponent rule. If n is a positive integer and a is a real number where a is not equal to 0, then our a raised to a negative n is equal to 1 over a to the positive n. Example, you got x to the power of negative 4. Just follow this formula here. And that is equal to 1 over x to the positive 4. Okay? Next. So in here, in our next example, 7 squared over 7 to the power of 5 is equal to 1 over 7 to the power of 5 minus 2. That is taken from the second condition of our quotient rule, where our m here, 2, is less than our m5, or that this one is equal to 7 to the power of 2 minus 5, and that would be equal to 7 to the power of negative 3. And then applying the last rule, the negative exponent rule, which is 1 over 7 to the power of 5 minus 2. That's why you got 1 over 7 to the 1 over 7 to the positive 3. Or simplifying further, you got 1 over 340. Okay? Next is p to the negative 1. Then, it would be 1 over p to the positive 1. Since our 1 should be omitted, that's why you got 1 over 3. Next is quantity 3x to the negative 3. Then, you have, since this is negative exponent, so applying the last part of our topic, the negative exponent rule, 1 over quantity 3x to the power of 3. And then you got 1 over 3 to the positive 3 x cubed. And then what is 3 to the positive 3 is 1 over 27x cubed. Okay? Very easy if you practice pag may time. Thanks for watching. Hope you learned from our topics. Please don't forget to like, share, and subscribe my YouTube channel. Bye for now. God bless everyone.
So, that's all for today, and we are done with the laws of exponents on different rules. So please study your lesson and don't forget to watch the video or keep on viewing our videos. Enjoy watching and don't forget to like and subscribe my YouTube channel. Bye for now.